Hello, welcome to TMT. I am Dr. Sanjay Shukla and today's topic is aldol condensation. So what we do today is we make a movie on organic chemistry. It sounds a little unusual, but we'll try to make a movie on organic chemistry. You have to guess the name of the movie somewhere in the middle of the talk. So for me to make any movie, the primary requirement is a good script, and a good script demands good actors. So I start my scripting with some good organic chemistry actors, and I got a lot of aldehydes and ketones lined up for today's movie. So if you can see the 5 structures which I've drawn, all of these structures are either aldehydes or ketones. Now the primary requirement for me to make this movie is the aldehyde or ketone, aldehyde or ketone, अपना hero है alpha hydrogen atom. Now before you understand what is alpha hydrogen atom, we should understand what is an alpha carbon atom. Any carbon which is directly bonded to the functional group is always known as alpha carbon. So when I look at the first structure, can you tell me the number of alpha carbon atoms here? The number of alpha carbon atoms are 0 because there is only functional group, no other carbon atoms. So the number of alpha carbon atoms in the first structure would be 0. If the number of alpha carbon atoms are 0, the number of alpha hydrogen atoms will also be 0. Okay, so alpha carbon here is 0 and alpha hydrogen is also 0. How about the second structure? You got this carbon as your alpha carbon, so the number of alpha carbon here would be 1 and the number of alpha hydrogen atoms would be 3. Going to the third structure, there is one alpha carbon. This is the alpha carbon directly bonded to the functional group, and the number of alpha hydrogen atoms are 2. Fourth structure, the number of alpha carbon atoms would be 2 and the number of alpha hydrogen atoms would be 6. Fifth structure. So when I go to the fifth structure, the number of alpha carbon atoms would be 2 again and the number of alpha hydrogen atoms would be 5. Yes. Going to the sixth structure, can you guess the number of alpha carbon atoms and the number of alpha hydrogen atoms? The number of alpha carbon atoms would be 2 and the number of alpha hydrogen atoms would be 5. Yes. The seventh structure, this is known as acetophenone. Acetophenone has got 2 alpha carbon atoms. Be a little careful with this carbon. This carbon is alpha carbon, all right, but it has no alpha hydrogen. So the number of alpha carbon atoms here would be 2, but the number of alpha hydrogen would be 3. Yes. Going to the eighth structure, this is a very tricky structure. Most of us make mistakes here. This is benzaldehyde. The number of alpha carbon would be 1, but the number of alpha hydrogen would be 0. Be careful about this structure. Going to the ninth structure, this is known as benzophenone. Benzophenone has got 2 alpha carbon atoms. These are carbon atoms directly bonded to the functional group. So the number of alpha carbon atoms here are 2, but the number of alpha hydrogen atoms are 0. The 10th structure, this is a random aldehyde, cyclohexane carbaldehyde. The number of alpha carbon atoms here would be 1, and the number of alpha hydrogen atoms would be 1. Yes. So if you understand the presence of alpha carbon and the presence of alpha hydrogen, our first job of selecting the candidates for the movie is done. तो हमारा पहला पॉइंट था कि एल्डिहाइड हो या कीटोन, अपना हीरो कौन है? अपना हीरो है एल्डिहाइड या फिर कीटोन, बट सारे एल्डिहाइड और कीटोन नहीं, ओनली दोज एल्डिहाइड्स एंड कीटोन्स which have presence of alpha hydrogen. So what we are going to do right now is we are going to select the people who can get into the movie, okay, and reject the people who can't get into it. So please guess, will the first molecule, formaldehyde, get into the movie? No. Why? Because it has no alpha hydrogen atom. Going to the second molecule, third, fourth and fifth, all of them are selected. That is because they have presence of alpha hydrogen. Sixth structure, it has alpha hydrogen, 5 alpha hydrogen with the sixth structure. Seventh structure has got 3 alpha hydrogen, so both of them are selected. Will the eighth structure be selected for the movie? No. Why? Because it has no alpha hydrogen. Sorry sir, you're out. Ninth structure, will it be selected for the movie? Though it has 2 alpha carbon, it has no alpha hydrogen. I'm sorry sir, you're out. And the 10th structure can also be selected because there is presence of alpha hydrogen. So our first point is done. Aldehyde or ketone अपना hero कौन है? Alpha hydrogen atom. Okay. Next is our movie has a theme of base. It is banana. It's either barium hydroxide, or sodium hydroxide, or you can use sodium carbonate. It's a small movie, small budget movie. The budget is only 10%. So you can either select 10% barium hydroxide, 10% sodium hydroxide, or 10% sodium carbonate. Any one of them. Okay. The third part of the movie. See, we are done with 2 points regarding the script of the movie. Now comes the third part. The third part is a very vital part. See, the orientation of an actor while delivering a dialogue is of utmost importance. See, everyone has their own ways and style. You remember Amitabh Bachchan standing with his hands on his waist? Yes. You remember Shah Rukh Khan making a semicircle? Yes. So today, my orientation of the molecule is very, very, very specific. How do I do it? You need two people to create a dialogue, log dialogue. So what I do is, I got two carbonyl groups, aldehydes and ketones. One of the aldehydes or ketones, I'll be drawing it this way. Extremely important for you to know the orientation of the molecule, because if you go wrong with the orientation, you are done and dusted with the reaction. But if you go right, you can have any complex structure and you can complete this reaction. Okay, so how have I created the orientation of the molecule? Now when you look at it with a lot of care, you got two aldehydes or ketones which are standing in front of each other. Can I say it this way? This is an alpha carbon, and alpha carbon, the hydrogen atom bonded with alpha carbon is alpha hydrogen. So if I see the orientation, I can define the orientation this way: alpha carbon, carbonyl carbon, alpha hydrogen, carbonyl oxygen, they are facing each other. I repeat, alpha carbon, carbonyl carbon, alpha hydrogen, carbonyl oxygen, they should face each other. So what I'll do is I'll write it here: alpha carbon, alpha hydrogen, alpha carbon should face carbonyl carbon, alpha hydrogen should face carbonyl oxygen, alpha carbon, carbonyl carbon, alpha hydrogen, carbonyl oxygen, they should face each other. आमने सामने आने चाहिए. Okay, once you are done with the orientation of the molecule, then it becomes easy for us to carry out the future part of the reaction. Now when I say carbonyl group, in the carbonyl group you got carbon and oxygen. Obviously oxygen is more electronegative than carbon, and because of that what happens is oxygen pulls the electrons towards itself. Bond pair becomes lone pair. Has oxygen lost or gained electrons? Gained. जो इलेक्ट्रॉन पाता है वो नेगेटिव हो जाता है और जो इलेक्ट्रॉन खोता है वो पॉजिटिव होता है. So the carbon here gets a positive charge and the oxygen gets a negative charge. I hope you understand the charges on the oxygen and the carbon. Talking about alpha carbon and alpha hydrogen, between carbon and hydrogen, obviously carbon is more electronegative, pulls both the electrons of the bonds towards itself. So has carbon lost or gained electrons? Carbon here has gained electrons, so it gets a negative charge. And hydrogen has lost electrons, it gets a positive charge. So what has happened is, the atoms which were facing each other, alpha carbon, carbonyl carbon, alpha hydrogen and carbonyl oxygen, the atoms which are facing each other have got opposite charges. And if they have opposite charges, there is huge case of them coming together and forming bonds. So can I write it this way? Alpha carbon goes with carbonyl carbon, alpha hydrogen goes with carbonyl oxygen. Yes, this orientation, how can it help us? We can have plenty of examples. What have I done? If you see these three examples, I have written the molecule in a particular orientation, and that orientation is alpha carbon, carbonyl carbon, alpha hydrogen, carbonyl oxygen, facing each other. In all of these conditions, I have written the same orientation. Now you can give me any example and I can complete the reaction by using the same orientation. Okay, let's talk about a molecule, any random molecule, like say for instance acetaldehyde. All right, so what I do is I simply satisfy the valencies in the given orientation. So two acetaldehyde molecules may undergo this reaction by using this orientation. Acetone, all right, I have no problems in drawing the structure of acetone this way, and I can complete the reaction with basic mechanism. Propionaldehyde, all right, any random aldehyde or ketone which has presence of alpha carbon and alpha hydrogen can be drawn this way. And n number of examples. Remember, till now we are done with 3 points. What are they? Alpha carbon, carbonyl carbon, alpha hydrogen, carbonyl oxygen, आमने सामने. Banana, barium hydroxide, sodium carbonate, 10%. And the most important requirement is either aldehyde or ketone which have presence of alpha hydrogen should be included. Okay, let's get on to the simple mechanism, working mechanism of it. We can have example of acetaldehyde. Okay, so this is acetaldehyde. If you remember, the orientation is once again done. Amitabh Bachchan on the left hand side with his hand on his waist. So I got acetaldehyde which can be drawn this way. Another acetaldehyde molecule which can be drawn this way. You can take any base of your choice, barium hydroxide, sodium carbonate. Make sure it is only 10%. Okay, once again, what will happen now? You have carbon and oxygen. Oxygen is more electronegative. Carbon and hydrogen. Carbon is more electronegative. एक स्लोगन है अपना, जो आमने सामने आएगा वो बॉन्ड बनाएगा. So am I right with this? Yes, you can check it. जो आमने सामने आ रहा है वो बॉन्ड बना रहा है. And finally, in any movie there is some kind of an emotion. What I do is there is some heat generated during the course of the reaction. Heat is the best form of dehydration. There would be loss of water. Now if there is loss of water, what do I get? Will the single bond become a double bond? Yes. This now becomes H. This remains as it is. So there is now formation of a carbon-carbon double bond. Yes. So we are done with the working part of the mechanism. What we can do now is we can think over the name of the movie. Now if you concentrate on the mid structure, if you look into the mid structure, this has got two important functional groups. One is this. What is this? This is an aldehyde. All right, so this is an aldehyde. I write ald. What is the other functional group? The other functional group is OH. OH is an alcohol. All alcohols are represented as all. So that becomes aldol. Now if you see the basic definition of a reaction where two molecules come together with lots of simple molecules like water, methyl alcohol, ethylene glycol, etc., such reactions are known as condensation. दो molecules साथ में आए और छोटे छोटे molecule अगर बाहर जाए, then it is known as condensation. Is there a loss of water here? Yes. Are both these molecules coming together? Yes. So can I sum up this reaction as a condensation reaction? Yes. So the name of the movie, if you have guessed it right, is Aldol Condensation. So quickly going through Aldol Condensation, there are 3 vital points. The first vital point is aldehyde हो या ketone, अपना हीरो कौन है? Alpha hydrogen atom. Alpha hydrogen है तो मूवी में आ सकता है, वरना घर जा सकता है. Then comes banana, barium hydroxide, sodium carbonate, 10%. Then comes the orientation, super important. Alpha carbon, carbonyl carbon, alpha hydrogen, carbonyl oxygen, आमने सामने. जो आमने सामने आएगा वो bond बनाएगा. And apparently there is loss of water, which is known as condensation. Now going into the real mechanism, I'll quickly go through the mechanism. I'll give you some acronyms to remember the mechanism. First is BAP-AC, where B stands for base. If you remember, this is a base catalyzed reaction, base, and this is alpha carbon. What happens is this alpha carbon is directly bonded to carbonyl group. Now carbonyl group has got multiple bonding. Do remember, anything which has multiple bonding, if you invert M, it becomes W. It is an electron withdrawing group. So what happens is the carbonyl group withdraws electron, and as a result this carbon has to pull electrons from this hydrogen. Base is always BAP. Base abstracts proton. Base loves proton. So base would abstract this proton. So bond pair becomes lone pair, and bond pair becomes lone pair, and lone pair becomes bond pair. As a result, what has happened is this carbon has gained electrons. Okay, so base abstracts proton from alpha carbon to give you this molecule. Now do you know this molecule? There is a negative charge on it. Charge है तो ion, negative charge है तो anion, and that negative charge is on carbon. Any carbon with a negative charge is known as carb anion. So this carbon ion, because molecule loves resonance. Any molecule loves resonance. It is like nasha for it. Lone pair becomes bond pair becomes lone pair, and because of that, you will see some kind of resonance. Now, when you see a double bond here, this can be known as ene. O के साथ अगर H होता तो we would have called as enol, but there is H missing. Because there is H missing, if there is H which is missing, it is known as enolate. Right? Yes, so base abstracts proton from alpha carbon to form enolate. Moving on, this enolate, carbon ion enolate, are undergoing resonance, and this enolate is in the form of carbon ion. It can attack another aldehyde molecule like this. Once again, lone pair becomes bond pair and bond pair becomes lone pair. So how do I define this step? It is very easy for us to define this step. This is carbon ion, and AT stands for attacks. Carbon ion attacks carbonyl carbon. CC stands for carbonyl carbon. So when I say cat CC, it is carbon ion attacks carbonyl carbon. So if carbon ion attacks carbonyl carbon, concentrate on this bond, there is new carbon-carbon bond formation, and this oxygen gets a negative charge. Yes, carbon ion attacks carbonyl carbon to give you this molecule, and apparently last part, this part, if I assume it to be capital R, this is R with O minus. This part, if I assume it to be R, this becomes RO minus, and RO minus is known as alkoxide. Alkoxides are also strong bases. My 10% barium hydroxide is actually made in water, which is a protic solvent. So this will now abstract proton. It will abstract proton, and that will form aldol. So how do I define ARP aldol? ARP aldol is alkoxide abstracts proton to form aldol. Key points in this reaction: there is new carbon-carbon bond formation, which is extremely important for us to know. Next, there can be crossed aldol condensation. If acetaldehyde reacts with acetone, that would be known as crossed aldol condensation. Intramolecular aldol condensation is also possible. If I have a molecule, this is hexane diol may undergo aldol condensation within the molecule. Why? Because there is presence of alpha carbon with alpha hydrogen, and also there is presence of carbonyl group within the molecule, Atmanirbhar molecule. So what will happen here is the same orientation. Once again, I have oriented the molecule in such a way that alpha carbon, carbonyl carbon, alpha hydrogen, carbonyl oxygen, amne samne. So what will happen? The atoms which are facing each other will come together, and if they come together, what may happen now is I am moving the alpha hydrogen here, and alpha carbon and carbonyl carbon will come together. Yes, we may also have dehydration. If there is dehydration, if there is a possibility of dehydration, H and OH moves out, and we may get a double bond. So apparently we will have a 5-membered ring with aldehyde, and the double bond is conjugated. So this is all about aldol condensation. There can be a lot of more complicated molecules which can be included. Also, let us talk about the molecules of aldehydes and ketones which were rejected. The ones which were rejected, let us talk about those molecules. They'll be included in another reaction, another movie that would be known as Cannizaro's reaction. Thank you.